Hey guys, so there was a little bit of a problem with my laptop a little bit ago. So this video is actually split up into two sections. So this you are watching the second section right now. So if you haven't seen the first one, make sure you stop the video and go back to the first section so you can see the whole front side of these notes for 2.2. All right. So we were going to go ahead and move onto subtraction. So just like addition, I'm going to encapsulate all of my f of x into one parenthesis. Let's go ahead and do that now. So this is going to be 3x minus 2x. Okay, now what are we being asked to do? Well, look, we're asked to subtract the other function. So I'm going to do a minus here. Actually, I can't really see that. I'm going to do minus. Okay, and once again, I'm going to write my g of x all in its own set of parentheses. Okay, now I'm hoping this will start to make a little more sense as to why I put it into parentheses, just like we did. So again, here I have a positive 1. If I were to distribute all of this out, I just get the exact. So 3x minus x plus 8. However, here I have a negative 1. If I distribute a negative 1 to everything, things are going to change. This now becomes a negative 1x squared. Negative 1 times negative 7x is a positive 7x. And negative 1 times 1 is a negative 1. So once again, for subtraction, it's vital that you guys go ahead and put those parentheses around the function, or else you will forget um, that you have to distribute a negative into all the terms. All right. So now all I'm going to do is combine like terms. Start with the larger ones. So what do I have here? 3x squared minus 1x squared is the next set of common terms or like terms that I see are the negative 2x and the 7x. So that gives me a positive 5x. And the last batch of like terms are the two constants. So we get positive 8 minus 1 is just a positive 7. All right. So hopefully you guys see now that it's very important to put that in parentheses. Like I said, in addition, you honestly don't need them. However, if you don't want to get in the habit of forgetting, then I would go ahead and suggest just showing parentheses there and distributing it out. All right. Now this last one for multiplication, same thing applies, guys. Write the entire thing, but instead of an h of x, you are now going to substitute that with whatever we have for h of x. So I'm substituting h of x for that. So I'm going to go ahead and rewrite what I have here, but I'm going to substitute that h of x. So what do I have? I have a negative 6 times, okay, and h of x. Like before, I'm going to put it all in parentheses. And once again, it's important to do that because now, look at that. What do I have to do as soon as I see a parentheses and something being multiplied on the outside? No, I have to distribute. Okay, so negative 6 times negative 5x, that's positive 30x. And then negative 6 times 9 is a negative 54. So my final answer is just 30x minus 54 because those two are not like terms. I cannot combine them. So I have a final answer. Okay, so that's again, recap there real quick. What did I do? All I did was I had an h of x there, so that's what I substituted in here, an h of x. Notice the negative 6 stayed exactly the same. I did not change that at all. All right, Okay, so what I want you guys to try out now on your own, since we've already done a few of these, I want you guys to try out number 13 and 14 on your own. I would actually suggest trying out number 14 because that looks a lot like the addition. We'll try that one first, and then go ahead and do 13. But you can try them in whatever order you want. Just remember, these are the two functions you're using. F of x and h of x. Alright, go ahead and pause the video and try out those two problems, and we'll look at 15 and 16 together. Alright guys, let's run through these problems real quick. So we have h of x right away at number 13. So I do 3x squared, and I'm going to get into the habit of putting them in parentheses, minus f of x, 2x squared, minus, oops, sorry, minus x plus 8. So again, f of x, which is highlighted here in blue, goes at the end. And the h of x, which is here in purple, or pink, whatever color you think that is, that's how we have it set up. So all I did, put the pink with the pink, subtract it from the blue. Okay, now I can go ahead and move forward. This first part right here, if there is an imaginary one in front of it, then honestly, nothing's going to change. None of the signs are going to change. So I can make this as 3x minus 10. However, here I have a negative 1, so I do have to distribute those out. So I get negative x squared plus x minus 8. Last step, as you guys know, combine like terms, get a 3x squared and a negative x squared. I have a negative with a negative 10, and that x all by itself. So my final answer here is 3, oh, I'm sorry, not 3. 3x squared minus 2x squared is 1x squared. The next thing I'm going to actually write is this x here. You can find it with anything. And then finally my constants. Those always last. So I put my negative 18. Alright, so that is my final answer. If you guys want to go ahead and write it. Go ahead. Alright, number 14. So f of x plus h of x. So let's go ahead and take my highlighter here. Actually, let's go ahead and write down the equation. Let's do that first. So f of x, well, put it all in parentheses. I keep doing that. I keep forgetting that x. I don't know why. X plus 8 plus h of x, which is squared is 10. Alright, so once again, I have my f of x, then I have my h of x. Okay? So again, if I were to distribute out this imaginary 1 in front of both, nothing would change, guys. For addition, if you want to distribute this step, that is totally fine. Just know that you can't quite do that with subtraction because you do have to distribute them if necessary. So let's go ahead and combine like terms. Okay, I'm just going to go ahead and highlight what I have in common here. So a few like terms are these. Okay, so let's move on to combining those. So 2x squared plus 3x squared is a 5x squared. The negative x doesn't combine with anything, so I'm just going to rewrite it. And finally, 8 minus 10 is just a negative 2. So this is your final answer. You can write it up on your answer line. So that is your answer. All right. So this one was kind of an oddball. because it wasn't one of the three examples we just did. However, it was one of the examples we did earlier on in these notes. So what are we using? We're using h of x, okay? So I'm actually going to go ahead and write h of x. But instead of writing x's everywhere, I'm going to just leave them blank first. So h of x equals 3, another blank parentheses, and actually let me scroll up a second, squared minus 10. But what are we substituting in there? Well, right away I see that there is a -2 inside my parentheses. So in every single set of parentheses, I'm going to write a -2. Okay, that's how we found values, x values. I'm sorry, that's how we substituted in x values into a function to our y values, just like we did earlier on in these notes. So what do I get here? Remember, in this step, you have to use PEMDAS. What's -2 squared? That's a 4. -2 times -4. So we did parentheses and exponents. Now I do multiplication. So 3 times 4, that's 12. Finally, addition and subtraction. 12 minus 10 is a positive 2. So h of -2 equals positive 2. Okay, so that one was out of the oddball out of the 4. And this one is the last example, just like the last example chart right above. Okay, so right away I see 5 times h of x. So the only thing that I am subbing in is h of x. So I'm going to go ahead and rewrite the problem as it is now. 5 times, but now h of x is what? H of x is 3x squared minus 10. And just like any other problem that has a parentheses like that, multiplying, then we actually have to distribute the 5. So what do I get? I get 15x squared minus 50. And I cannot combine those because they are complex terms. So I just write my final answer. Alright guys. So I guess I just want to apologize real quick for the cut in the middle of the video. I do apologize for that. It is a technical error with my computer at the moment. But I hope that this kind of helped you guys out with section 2.2, and hopefully you're better prepared and have a better understanding of what a function is and how do we perform operations on those functions. Alright guys, so go ahead and stop the video at this time and move on to 2.3. See you guys.